In 2013, a paleoclimatology expedition on Maly Lyakhovsky Island in Yakutia was digging a trench through a deep ice lens. The air temperature was around -17 degrees Fahrenheit. All around, just the ringing Arctic cold and concrete-hard, permafrost-bound ground. But when a steel pickaxe broke off a chunk of ancient ice from beneath the belly of a frozen female mammoth, something happened that should have been physically impossible. A thick, dark red liquid slowly began to flow out of the dark ice cavity at -17 degrees from a body that had been buried underground for 30,000 years. The scientists froze. Physics was literally breaking apart before their eyes. The liquid didn't freeze, lazily dripping over ice crystals into a test tube. That day, biologists realized the permafrost hides anomalies that don't just argue with nature, but shatter our basic understanding of death. Beneath the Siberian tundra, the ice shell goes down a mile and a half. That's 2 Burj Khalifa skyscrapers buried one under the other in eternal darkness. If a living human were to end up there, the dry Arctic cold would suck the moisture from their cells in hours, and the lithostatic pressure of the ground would crush their bones with the force of a hydraulic press. A ringing silence reigns here, smelling of 30,000-year-old death and wet ancient silt. It's commonly believed that permafrost is just a giant natural freezer, perfectly preserving the past in its original state. That's a dangerous misconception. Permafrost is a slow tectonic press, a chemical reactor, and a biological time bomb. Today, we're going to start peeling back this ice shell, layer by layer, like paleontologists removing soil from a dig site. We'll start with simple tourist tales about dinners of mammoth meat and descend to the terrifying physical laws of cryobiology. We'll pass through the soot of the first human campfires in the treeless tundra, deconstruct the ambitious genetic hacking of Silicon Valley billionaires, and finally hit the deep, sealed water of Pleistocene oceans, trapped under incredible pressure. And when we reach the very bottom of this well, if you're ready to descend to that depth and find out what our planet's dark side hides, hit the subscribe button. We're starting the dig. Internet sensation lovers love to tell fairy tales about lavish banquets where scientists and high-ranking guests are served steaks from freshly thawed mammoth. Bloggers with serious faces film reviews, grilling fibrous chunks of brown meat over a campfire. They claim it tastes like tough horse meat with a slight gamey flavor. A beautiful legend. Complete nonsense from start to finish. The reality of paleontological finds is far from a restaurant menu. The meat of an animal that's lain in frozen ground for 30,000 years physically can't remain meat in the way we understand it. Even in a perfect natural insulator, processes occur that turn muscle fibers into something completely different. For starters, over that time, cells undergo extreme destruction. The water inside them freezes, turning into ice needles that tear apart the cell membranes from within. Tissues lose moisture through sublimation. Ice slowly evaporates directly into the atmosphere through microscopic pores in the soil. The dense muscle tissue of a mammoth turns into a dry, fibrous, dehydrated sponge. But the most interesting thing happens to the fat. In the absence of oxygen, with high groundwater humidity and consistently low temperatures, the fatty tissues of mammals kick off a process of anaerobic decomposition. This is called hydrolysis. Special bacteria from the genus Clostridium come into play. They can multiply even without oxygen. They slowly break down triglycerides into fatty acids. Over time, these acids react with calcium, magnesium, and iron ions dissolved in the surrounding groundwater. The result of this chemical reaction turns what was once soft subcutaneous fat into adipocere. In medicine and forensics, this phenomenon is called adipocere, or, to put it bluntly, grave wax. On the outside, it looks like a grayish-white, crumbly mass that vaguely resembles cheap, moldy cheese or laundry soap. The smell of this stuff is distinct. It's dense, cloyingly sweet, with sharp notes of ammonia, dampness, and aged manure. You can't mistake it for anything else. The smell of the dead Pleistocene soaks into researchers' clothes within minutes. Getting it out afterward is an impossible task. You're better off burning the clothes. If you try putting a chunk of this meat on a hot skillet, you're in for a crushing disappointment. Instead of a nice crust and the aroma of medium rare, your kitchen will instantly fill with the suffocating stench of a rotting corpse. Heated grave wax doesn't fry, it melts. In just a couple of minutes, that brown chunk turns into a cloudy, grayish, soapy emulsion with dry, tough collagen strands floating in it. Trying to eat that dish would guarantee severe toxic shock. Your stomach would simply refuse to digest the metallic soap created 30,000 years ago. All those stories about tasting Pleistocene steaks? That's just a marketing gimmick to attract tourists. In the Klondike or the Arctic zones of Yakutia, gullible travelers are often served regular wild boar, bison, or horse meat disguised as ancient game, pre-soaked in a special brine to make it tough. Real mammoth is inedible. Its tissue is dead chemistry, turned by time into a waxy, soapy mass. Permafrost doesn't preserve life, it preserves death, slowly rewriting the body's chemical formula. And to understand how this preservation mechanism works, we need to go deeper, to where ordinary water becomes the most dangerous destroyer of living cells. Ice is a ruthless killer of living cells. When regular water freezes, it expands by about 9%, and its molecules arrange into a rigid hexagonal lattice. The sharp ice crystals inside a cell act like microscopic scalpels. They easily pierce the thin cell membrane. A living cell literally bursts like a water balloon. When the temperature rises, the tissue turns into a shapeless, slimy mush. That's why modern science still can't freeze people for interstellar travel. We'd just turn into a pile of ice shards. But evolution, over millions of years, has found workarounds. The most striking example is the Siberian salamander. This unremarkable little amphibian can handle temperatures as low as -55 degrees Celsius. The secret to its survival lies in chemical substitution. As soon as the air temperature drops below freezing, the salamander's liver kicks into overdrive. It releases massive amounts of glycerol and glucose into the bloodstream. The water inside its cells gets replaced by this concentrated syrup. In extreme cold, this solution doesn't freeze into ice, it thickens, smoothly turning into an amorphous solid. The concentrated state. Physicists call this process vitrification, or glass formation. Inside the salamander's cells, inert organic glass forms without a single sharp crystal. The animal literally freezes solid, turning into a fragile amber statuette. Come spring, that glass melts. The salamander just comes back to life and heads off to find food. Mammoths had a much tougher challenge. They had to maintain a constant body temperature of around 37 degrees Celsius while standing on frozen ground under hurricane-force winds. Their main weak spot was the trunk. That huge, boneless muscle organ sits several meters away from the heart. In modern Asian elephants, severe cold makes blood thicken fast, and hemoglobin locks onto oxygen so tightly it refuses to release it to the limb tissues. Instant frostbite and necrosis set in. Mammoths solved this problem at the genetic level. Their hemoglobin went through 3 key mutations that completely changed its properties. Mammoth blood had no trouble releasing oxygen to muscle tissue, even when the trunk temperature dropped to nearly 0 degrees Celsius. Essentially, an optimized antifreeze oxygen carrier was circulating inside their bodies. But you can't survive on physiology alone. Nature had to work on the exterior design too. Study of the Maly Lyakhovsky mammoth's trunk revealed unique lateral skin outgrowths. They were like fur pockets. When the mammoth rested, it could curl its trunk into a ring and tuck the sensitive tip into these warm folds, like putting it in mittens. Even the mammoth's anus was covered by a dense woolen flap. There are no trivial details in the evolution for survival. Your butt can't freeze. Now let's get back to the phenomenon of the liquid blood that flowed from the Maly Lyakhovsky female mammoth at -17 degrees Celsius. This wasn't living blood in the strict biological sense. What we're looking at is the product of slow tissue breakdown inside a sealed ice capsule. When that multi-ton female fell into a swamp and froze quickly in pure ice, her circulatory system became completely isolated from the outside world. Over 30,000 years, the red blood cell membranes fully disintegrated. Hemoglobin mixed with lymph and interstitial fluid. In that confined space, the concentration of nitrogen compounds, urea, and potassium salts gradually increased as proteins broke down. An ultra-concentrated saline solution formed underground. It's a classic physical-chemical law, freezing point depression. The resulting brown sludge physically couldn't turn into ice under typical Siberian frosts. It waited its turn for 30,000 years. The human body lacks these protective mechanisms. Our blood crystallizes quickly, and limbs die off at the first signs of deep hypothermic shock. We are delicate tropical creatures who survive in the north only because of burned fuel and warm clothing. If you've made it to this layer and your brain hasn't boiled over yet, write the word abyss in the comments. I need to know who's going with me all the way to the bottom. In the next layer, we'll peel back another stratum of time. We'll learn how our ancestors managed to survive in this icy hell without electricity, central heating, or puffer jackets. In old-school history textbooks, they often drew the same classic picture: a group of half-naked savages in animal skins, shouting as they drive a giant mammoth into a deep, pre-dug pit with sharpened stakes at the bottom. It's a pretty picture, except it has nothing to do with historical reality. It has nothing to do with... Anyone who's ever been to the far north would laugh at this artist. Try digging even a small hole in the permafrost with a bone pick or a stone axe, preferably in winter. Frozen ground is harder than high-quality concrete. It's a monolith of frozen quartz sand, silt, and pure ice. Even today, professional builders use heavy excavators with hydraulic hammers to dig trenches, or they preheat the ground with jet burners. Savages with stone tips would have died of exhaustion at the edge of their unfinished pit long before they got even half a meter deep. Our ancestors were anything but fools. Why waste energy on digging when nature itself had already made perfect traps? Pleistocene hunters used the natural landscape. River bluffs, deep ravines, and swampy thermokarst bogs. A mammoth weighed about 4 tons. On the hard, dry ground of the tundra steppe, it was perfectly comfortable. But during the short summer thaw, the top layer of soil melted, turning lowlands into sticky bogs. Once a heavy animal stumbled into such a mire, its own weight became its death sentence. The multi-ton giant would instantly sink into the mud up to its belly. Driving a panicking beast toward a bog trap with torches and shouts wasn't hard. Hunters would finish off the stuck, helpless mammoth from a safe distance using long spears with tips made from split ivory. The most stunning evidence of this extreme survival was found by paleontologists in northern Yakutia. The famous Yana site sits at 71 degrees north latitude. This archaeological sensation is about 32,000 years old. People lived there right at the peak of the last glacial maximum. It was the era of the so-called Beringian standstill. Huge glaciers 3 kilometers thick trapped human populations on a narrow isthmus between Siberia and Alaska. People were locked in a cold, dry, nearly treeless expanse. This raises a logical physical question. How do you keep warm in the tundra, where winter temperatures drop to -50 and there isn't a single tree around? No pines, no birches, not even polar willows. Humanity hadn't learned to heat homes with coal yet. The solution was cynical and effective. People burned the bones of the animals they hunted. A fresh long bone from a mammoth or woolly rhinoceros is 30% fat and bone marrow. If you light a small tinder of dry lichen and mammoth dung, then surround it with large bones, you get a steady, long-lasting fire. The temperature in such a hearth reaches 700 degrees Celsius. Bone fuel burns slowly, releasing enormous heat. The hearth at the Yana site smoked around the clock with thick, oily black smoke. It smelled of burnt fur and rendered fat. That heavy smell of Pleistocene survival was the main aroma of human dwellings for thousands of years. Life at the Yana site wasn't a primitive struggle for existence. Archaeologists found there the finest bone needles with drilled eyes. With these tools, people sewed waterproof multi-layer clothing from Arctic fox and polar hare skins. They made complex composite spears with tips from straightened mammoth tusk. To straighten the spirally twisted, The tusk was soaked in hot water for a long time, then carefully straightened in wooden clamps. This was high-level Stone Age engineering. These highly specialized hunters of big game knew animal anatomy and material properties down to the finest detail. But that perfect adaptation ended up backfiring on them. When the climate started shifting and the tundra steppe began turning into modern-day swampland, the mammoths started leaving. And following them out went the era of the great hunters. In the next layer, we'll uncover the most technologically advanced layer of our history. We'll figure out why today's billionaires are pouring insane amounts of money into bringing these giants back to Siberia, and why this whole venture reeks of a massive scam. Every few years, global media explodes with headline frenzy. We're promised the first live mammoth will be born in just 3 years. Journalists paint Jurassic Park-style pictures. The public believes that geneticists found an intact cell in the permafrost, thawed it out, and implanted it into an elephant's womb. That beautiful script works great for sci-fi movies. In the real world, it doesn't fly. Cloning a mammoth using the classic method is impossible. For traditional cloning, you need a whole, undamaged nucleus from a living cell with fully intact double-stranded DNA. But death kicks off an irreversible process of molecular bond breakdown. Enzymes start chopping the long polymer chains of the genome into random fragments. Background radiation from the Earth's crust also takes its toll. The half-life of DNA is about 521 years. After 30,000 years in an icy grave, the mammoth genome turns into chaotic dust. The average length of surviving DNA fragments from Pleistocene finds is only about 50 base pairs. Trying to assemble an intact, working chromosome from those scraps is like trying to restore an archive library after a direct thermonuclear strike. There's just too little information left. Time has destroyed it. That's why the project by the American startup Colossal Biosciences isn't about cloning at all. They're using a strategy called molecular patch design. Scientists took the Asian elephant genome as a foundation. It matches the mammoths by 99.6%. These are essentially the same animal. Using computer modeling, biologists compared the two genomes and identified roughly 60 key genes that set the northern giant apart from its warm-loving southern cousin. Then comes the delicate surgical work at the molecular level. Geneticists use the CRISPR-Cas9 technology. Think of it as a pair of ultra-precise molecular scissors. With these, they cut out the native segments from the Asian elephant's DNA and replace them with lab-synthesized mammoth genes. They tweak the code responsible for fur density, ear shape, subcutaneous fat thickness, and hemoglobin structure. What's supposed to be born in labs by 2028 won't be a woolly mammoth. What will emerge is a deeply modified Asian elephant, a hairy hybrid, a mammophant. It's a product of genetic engineering, adapted to extreme cold. Imagine taking a modern city hatchback, slapping on off-road tires, welding steel plates onto the body, and painting it in camouflage. It looks like an armored vehicle, but inside, it's still a city hatchback. So why are investors pouring hundreds of millions of dollars into this project? The answer is cynical. It's not about love for ancient fauna at all, and it's not about saving the Arctic climate. The real goal is patents on the underlying technology. To grow a modified baby mammoth, scientists have to solve some insanely complex engineering problems. They need to master ultra-multiplex gene editing without causing collateral mutations. They'll have to build an artificial womb on a massive scale, capable of incubating and nourishing a 200-pound fetus for 22 months. The patents on these medical and veterinary breakthroughs would be worth billions. They could be sold to pharma giants and agribusiness conglomerates for use in human medicine and livestock breeding. The mammoth is just a giant, hairy billboard, a way to draw in cash from gullible venture capitalists, a beautiful front for selling future patents. But if this genetic startup actually pulls it off, and a herd of woolly elephants is really released into the Siberian tundra, the consequences could be wildly unexpected. We might wake up forces that have been sleeping under the ice cap for hundreds of thousands of years. And those forces aren't hiding in mammoth DNA, they're in the physics of the permafrost itself. Most people imagine permafrost thaw as harmless muddy puddles appearing on the polar plains, just another scare story from the evening news. But in reality, this process is more like the slow collapse of a skyscraper's foundation. Permafrost isn't just frozen dirt. It's planetary-scale cement that holds millions of square kilometers of land stable. When that cement turns to water, the landscape loses its load-bearing capacity. Houses in northern cities crack wide open. Multi-ton bridge supports sink. Railway tracks twist and warp like strips of clay. Polar infrastructure is crumbling before our eyes. But beneath this surface chaos lies a far bigger hydrogeological anomaly. Deep under the ice cap of western Siberia, trapped in Jurassic-era sandstone, sits a colossal artesian megabasin. According to geophysicists, the volume of fresh thermal water locked in there equals 10 Lake Baikals. That water is under enormous formation pressure. The permafrost acts as a gigantic, rock-solid ice plug, sealing the reservoir from above. If that plug loses its strength and thins out, physics takes over. We're looking at massive artesian blowouts. Pressurized hot water will blast its way through weakened ground, erupting in giant thermal springs. Vast areas of western Siberia could turn overnight into warm, boiling thermokarst lakes. The landscape would simply drop, swallowing drilling rigs and compressor stations. Another hidden enemy of the permafrost, gas hydrates. These are solid crystalline compounds of water and methane that stay stable only under high pressure and low temperature. They look like compressed snow, but if you put a handful on a table, it will burst into a steady blue flame. As temperatures rise, gas hydrates instantly decompose. Methane turns to gas, expanding in volume by a factor of 160. Trapped under a dense layer of clay, the gas creates zones of extreme pressure. Eventually, there's a colossal underground explosion. That's exactly how giant craters form on the Yamal Peninsula, dozens of meters deep, with perfectly smooth edges. It's not trails of meteorite impacts. These are massive methane eruptions. The Earth is literally exploding from within, blasting millions of cubic meters of greenhouse gas into the atmosphere. But the fastest, most tangible threat is microscopic. The ice sheet hides billions of tons of ancient organic matter, preserving billions of spores of dangerous microorganisms. In 2016, Yamal experienced a record heat wave. The thermometer hit 35 degrees Celsius. The permafrost thawed to an unprecedented depth. Meltwater eroded an old livestock burial site from 1941, where reindeer carcasses killed by anthrax had been laid to rest. The spores of Bacillus anthracis proved nearly immortal. They spent 75 years locked in ice without oxygen or UV exposure, retaining 100% viability. Once they hit warm water, the spores activated instantly. The result was swift and terrifying. Over 2,000 reindeer dead, dozens of Nanette's nomads hospitalized, and an emergency deployment of military radiation and chemical defense units. One scorching summer was all it took to wake an ancient killer. Anthrax is just the tip of the iceberg. The permafrost holds smallpox reservoirs, strains of the Spanish flu, and ancient giant viruses that have been dormant for 30,000 years, all waiting for their moment. The physics of melting is irreversible. And while scientists argue over climate models, those who work on the permafrost every day see its dark, criminal side. While armchair geneticists in Boston theorize about saving the planet with woolly elephants, a very different, pragmatic, and dirty war is being fought in the Yakut tundra, a war for the white gold of the Pleistocene. Every year, hundreds of illegal prospectors head to remote northern regions in search of mammoth tusks. It's a lucrative black market business worth tens of millions of dollars. The main buyer of this raw material is China. There, mammoth ivory is valued at its weight in gold. It's carved into expensive figurines and personal seals for the local elite. A seal made from tusk is the ultimate status symbol. The methods used to mine this gold are far from scientific paleontology. To retrieve the coveted bone from the permafrost, prospectors use powerful diesel water pumps. They suck up icy water from northern rivers and blast it under dozens of bars of pressure at frozen coastal cliffs, the Yadomas. The water jet works like a hydraulic cutter. Centuries-old ice instantly melts, exposing ancient skeletons. Entire hills are washed into rivers, leaving behind lifeless landslides and mountains of liquid mud. River water turns into an impassable, silty slurry. It clogs fish gills, destroys spawning grounds completely, and wipes out the local ecosystem for miles downstream. It's a textbook case of environmental self-sabotage for quick profit. The Batagayka crater stands as the ultimate monument to human stupidity in the permafrost. Locals call it the gateway to the underworld. In the 1960s, this spot was just a clearing in the taiga. They cut the trees to build a dirt road. The thin protective layer of moss and turf was broken. Sunlight started warming the exposed clay soil. Today, the Batagayka crater is a giant, ever-expanding chasm over a kilometer long and up to 100 meters deep. It grows at a rate of up to 15 meters per year, devouring the surrounding taiga and exposing permafrost layers up to 200,000 years old. Along the crater's edges, you can hear a constant, low groan, the sound of walls collapsing under their own weight. The ice walls are retreating, releasing ancient mud, and this scar on the planet's surface is clearly visible even from space. Permafrost was never our friend. It's a cold, silent overseer, holding the planet's past in an iron grip. We try to conquer its depths, dig out its treasures, resurrect its dead ghosts, and bend its laws to our will. But every step we take only loosens the knot. The ice is melting, and the deeper we dig, the clearer it becomes. Some things should stay frozen forever.